Okay, today I will be doing homework 3, question number 8, and my name is Angel Edwards. So, what we will be doing in this problem is we will be finding the derivative of the integral from 2 pi to the third root x of cosine t dt. And we have to do this 2 different ways today. The first way we do this, A, we'll be using the second part of the fundamental theorem of calculus, which states that when integrating from a to b, f of x dx, it equals the antiderivative of b minus the antiderivative of a. So, first, by evaluating the integral and differentiating the result, well, first I'll have to find the antiderivative of cosine t, which is sine t plus c. And after knowing that, I can write it out like this. 2 pi cosine t dt equals the antiderivative of third root x minus the antiderivative of 2 pi, which is the same as saying sine t, evaluating it at both third root x and 2 pi, because sine t is the antiderivative of cosine t. And so now we evaluate. Sine 3 third root x minus sine 2 pi. Which, because sine 2 pi equals 0, and you can solve this by using the unit circle or just by memorizing, but I know that sine equals 2 pi, sine 2 pi equals 0, so you can just scratch that off, and it equals sine third root x. So now, we differentiate the value of the integral, and remember to use a chain rule for derivatives. So, dx, this marker is drying out, so I'm going to switch markers to a really pretty green. Great switch, actually. Okay, so dx integral from third root x to pi cosine t dt will equal, taking the derivative of d dx, sine third root x. And this equals cosine third root x times d dx 3 root x, which equals cosine 3 root x times 1/3 x to negative 2/3. Therefore, d dx equals the integral from third root x to pi cosine dt equals 1/3 x to negative 2/3. And this is just based on basic integration, cosine third root x. Okay, and that's the answer using the second part of the fundamental theorem of calculus. Now I have to show you the same problem a different way, and this will be using the first part of the fundamental theorem of calculus. So to do this, we will differentiate the integral directly according to the first part of the fundamental theorem of calculus. So the first part of FTOC states that the derivative of the antiderivative equals basically d dx of the integral from x to a f of t dt, which also just equals f of x. So now we have to use a chain rule to differentiate. To do this, we will make u 3 root 3x because we're still using the same problem we were using before. So we make u 3 root x and dx, we have to substitute 3x 2 pi cosine t dt equals cosine 3 root x dx 3 root x, which equals 1/3 x to the negative 2/3 cosine 3 root x. So, oops, that looks really, really ugly. So, as you can see, I used the first part of the fundamental theorem of calculus and the second part of the fundamental theorem of calculus, and we have the same result.